Hey everybody, this is Larry. This is day 12 of the April Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I kind of went back to the gym today finally after a week of just craziness. And what else? Oh yeah. I also want to say, I did, just to be clear, I think I talked about it the last couple of days. I did lose a lot of money. It is not great, and not just from SPY or S&P 500. I lost a lot of money on top of that. So I did a lot of silly side bets. They weren't silly. I think actually the math ended up okay. I just kind of or some part or the strategy was okay, but I think I just didn't. I don't know. I just didn't want to deal with it, and eventually the math was right, and I got out a little bit before, unfortunately, because I don't know, things are just crazy, right? But that said, yes, it does suck, but it's not like it's not life changing per se. Like I'm not like ruined or anything. I'm not like but it's still just not great, Uh, but it is what it is. It is just a lot of money. So, but that's basically the thing. I'm okay, but it's still like you think about wow, like a year of gains or whatever gone or something, right? So and it's like, what am I doing? But it is what it is. Sometimes, at least I have the luxury of kind of you know still have a lot, so it's okay. Anyway, let's take a look at today's problem. We have 3272. Find the count of good integers. Hey everybody. So I'm cutting it in because this video went way too long. And honestly, I don't remember how I did it last time or in terms of like performance wise, but it wasn't so bad. I think I just kind of, in a retrospective kind of way, I just prematurely thought that this whatever I did here would be too slow. But if you look at the math, everything is pretty fast, so maybe that's why. It's not super fast, but it's not super slow, and apparently it's not slow enough. But we'll go over the math. Anyway, for this one, you just kind of generate. So I did this problem incorrectly because I thought that, well, I didn't think this, but I didn't realize that I implemented it this way. Is that I was solving it such that I didn't solve the rearranged part correctly with respect to the divisibility, right? And the reason I say that is that for palindromes, if you rearrange the palindromes, right? It just becomes a parity thing, right? Meaning counting the number of odd parts and the number of even parts, and you can flip it around. So I did a DP based on that, and divisible by k in a DP, digit DP kind of thing is pretty straightforward. Not going to, maybe not, but I'm not going to go over it here because that's the wrong solution. But as a result, I merged them together in an incorrect way, right? And yeah. So the key part about this one is turns out, just construct every possible thing. And I thought that it would be too slow, but I was wrong. First of all, well, we constructed every possible thing, but only after, and then counting the number of things from that thing, right? And okay, so what I mean by that is that here you can construct all the possible right answers. So we'll construct all the possible k palindromic integer first, and then we back do the math to count the number of digits. And what I mean by that is that, for example, if you have n is equal to 10 digits, and for easy saying, I'm just gonna say half the digits is gonna be 5 digits. So then now you can say, okay, well, there are only 100,000 unique numbers to test out, right? Because here, this is one of them. This is the next one, right? This is the next one, and then ... right? And all the way to all nines, and just add an extra one for visualization, right? And then now for all these numbers, you can just test whether it is equal to k, right? Or I'm sorry, mod k is equal to 0, right? Whatever k is, whichever one is fine, right? And then okay, so then what happens after that, right? Well, after that, then it just becomes math, because for each one, one is that we don't want to duplicate it, right? Because okay, let's say let's say k is equal to 1 because it's just easier to dedupe that way, right? Then you have like if you have this and you have this, it's fine. They're two distinct things, but if you have an maybe that's where k equals 1 not. Okay, let's change it a little bit, right? So here, let's look at k is equal to 5, right? So we have, well, 515 is the palindrome, but it also means that 551 is good. And let's actually add a couple more digits. Sorry, friends, I'm like very not good at explanation today. But yeah, so this is good, but also this is also a good number, right? And even probably this one is a good number. And that's fine. They're unique, but they're all permutations of each other, right? So you don't want them to count multiple, right? Like you don't want you don't want to double count. So what you can do is, of course, is dedupe, and then just oh wait, actually, yeah, this is actually a good example because for k is equal to 5, actually this is a good number and this is a good number, but this is not a good number, right? So if you count these two, you also have to count this one because this one permutates into these along the other, and this is a palindrome, but and of course there are other ones too, right? Like also because this maps to one of these, right? So as a result, you have to establish, if you only count two of them and not the third one, the palindrome ones, because that's where we're looping, then you're going to have some wacky math. So the way that I would, or I did do it, in fact, is just by mapping them to a key. There are a couple of ways you can think about writing this, but you could, for example, just compress this to like 2 1 5 4 2 1s and 4 5s, right? Something like that. So you could compress it in that way and then just like dedupe them, right? And then now, but once you have it like this, then how many combinations of 6 digits can you have? Well, with 6 digits, then it just, and this, I'm not going to go over in too much detail in the sense that this is a combinatorial problem, right? Here, then you have 6 factorial because that's just the number of things. And then to dedupe is over 4 factorial over 2 factorial. I'm going to go over this in detail. Like I said, this is a combinatorial counting thing. I'm not going to show you any proofs, but that's basically the idea, is that it is n factorial over the product of the individual parts and like I call it like v factorial for v, or v sub I factorial for all i's, which is the number of these things, right? Okay, so that's basically it, really. There's one more thing, or a couple more like weird cases, right? One with the odd numbers, or odd number of digits. For example, if you have to, you have to take account like, this is like if you generate these numbers, we generate like this here. You have to generate, let's say you have n is equal to 9 digits, then you have to generate, say, something like this, and maybe the middle digit is going to be that, right? And then and then so forth, right? And then you try like, and then so forth, right? I mean, you get the idea, I think. It's just generating numbers in a different way. And then the counting, so this is one special case, I guess. And then the other special case is around, it's not that special, but it's about leading zeros, right? So leading zeros, there are a couple of ways to do it, or 2 ways to do it at least. But for example, if you have, I don't know, let's just say like you have 4 8s, 4 zeros, 4 8s, and this is too many digits, but I'm just doing, giving you an idea, right? So something like this, right? Well, there are 2 ways to do it, right? One is just counting out, okay, how many numbers that you count literally how many numbers that are not leading zeros, right? So here you can say, okay, if the first number is 2, then what happens? If the first number is 2, if the first number is 2, then you have, let's see, this is 12 total numbers, so it's going to be 11 factorial, because we fixed the first number is 2, and then that's going to be 11 factorial over 4 factorial for the 8s, 4 factorial for the 0, I said it the wrong order, but and then 2, which is 1 factorial because you used one of the 2's for the first number, and then 2 factorial for the 5. So it's this plus first number is 8, right? Or 5 you can do, which is exactly the same thing actually, right? Plus first number is 8, right? So same thing-ish, except for now it's 4 factorial, 3 factorial, 2 factorial, 2 factorial, right? Because we took one from the 8. So that would give you an answer. And then the other way, of course, is just subtracting out the zero, the permutations with leading zeros, right? So here, instead, you can also do like 12 factorial over all the things minus first number is 0, which is 11 factorial. I think is 1 with 3, so it's something like this, right? And yeah, and that's basically how I did it. We'll go over the code really quick, and if you really want to watch how I come up with this, well, watch the rest of the video. But yeah, first, I don't know, I just was too lazy to deal with a special case. So I guess I did have an extra special case of we have 1 digit and just do a for loop, right? Too lazy. Okay, and then now it just becomes an odd even thing. I just put everything in this thing called set to dedupe. There are a number of ways you can dedupe, but it's just like I said, it's just a thing where you dedupe it to something like this. The way that I did it is by taking all the digits and then sorting them. Yeah, take all the digits and then sorting them, and then put in key, right? So it's kind of like a frequency map. So like for example, if your key or if your number that you're testing for is like something like this, then it just kind of sorts all the digits to like 2255555, right? Something like that. So then, because if you sort these, it's just used for deduping, right? And the count is not necessary. I just kind of had this for debugging, actually. Now that I guess I left it in there. So yeah, and if we have even number of digits, it's just the first half plus the reverse of the second half, right? And if we have odd number of digits, then it's the first half plus one of the 10 digits in the middle half, and then the right half, right? And that's it for this part. It generates things into the set, so we have a unique thing for the set, right? And yeah, we have n factorial, and I don't know. Okay, I wrote this for a little bit of efficiency, but I just kind of didn't go all the way. But yeah, it's just factorial numbers, and then now this is all the things we're saying, right? So we start with n factorial. I guess this is for here. Yeah, we tried to subtract out the 0 leading thing. So this is all the possibilities, right? That's the n factorial over the component factorial, and here is fixed one of the digits to one of the zeros to the first digit, and then we just subtract that out here, and then we add that to total, and then we just sum over all the total, and we're good. And that's it. Yeah. Is that? I mean, we could go over complexity in the complexity sense, but really, this just kind of go over. I mean, it's exponential. It's a short story because it's way small. But yeah, like for n is equal to 5, it goes. Well, this loop does 100,000 things. Each of these does like 10 things ish, right? I mean, it's not cheap 10 things, but still. Right, for here, and then just sorting 10 elements, which is also roughly 10-ish, right? Like maybe a little bit more, but okay. Same thing here, because this is, this is gonna be 10 that factor of 10 smaller times 10, so it's the same, right? Yeah, so that's just like 10 to the n over 2 times n, I suppose. Yeah, where n is the number of digits, and then here it is just O of 10, right? Because you have at most 10 objects, and you have if statements. So yeah, and that's it. That's all I have for this one. You could watch me solve it during the live thing next. And now, thanks for watching. You're given two positive integer n and k, and integer x is called k palindromic if x is in palindrome. X is divisible by k. An integer is called good if its digits can be rearranged to form a k palindromic integer. For example, for k is equal to 2, 2020 can be rearranged to form the k palindrome integer 2002, whereas 1010 cannot be rearranged into a k palindromic integer. Wait, what is the k part again? If its digits can... Does it say later? Oh, no, I said it before. X is divisible by k. Okay, so that part I missed. I don't know, I'm reading too fast, maybe. Excuse me. Return to count the good integers containing n digits. Okay, note that any digit must not have leading zeros, neither before nor after the rearrangement. That's fair. Okay. Yeah. I mean, this is just an example, and okay, what are constraints? Oh, constraints are 10 and 9. Maybe that's okay. I don't know. We'll see. Yeah. So n is the number of digits, is it? What is n again? Okay, n digits. I was looking for the n. I don't know why they... I mean, I know that this is like a highlighting thing, but they bold so many things that... But they didn't bold n, so I was like, where am I looking for? Okay, n digits. Just want to confirm. Okay, I don't know, I'm having trouble reading. And k is the divisibility. Okay, and n is up to 10, so it's not a big number, and k is up to 9, which is also not a big number. So what are the answers here, right? Well, okay, let's kind of think about it. I think the first thing that, and I don't know how much, I think the problem, so just to be clear, at this point, I do not remember the problem, right? It feels recent because of, and I only say that because I recognize it by the problem number that feels recent, like it's a new-ish number from like a contest that I probably have done, but I don't remember anything about this, honestly. Or maybe, or not explicitly, right? And what I mean by that is that maybe on a subconscious level, there's something that I know, but frankly, I don't know. I so we'll see. The first thing is that k is equal to 9 is maybe interesting because that means that I don't know. I don't know if we need to pull this out, but that means in theory, like in theory, you could do an if statement on 9 cases if it comes out. I don't know if it does, right? Like if k is equal to 1, then is everything. K is equal to 2, then etc. Right? Yeah, I don't know. I don't know if that's And also another thing to keep in mind is that we don't have to be super fast on this one on the complexity wise. Because n is only up to 10 and k is equal to 9, which also means that there are only at most 90 inputs, right? And as a result, what is n to the 9 is a billion, right? Is it? And n to the 10 to the 9 is a billion, and 10 to the 10 is 10 billion, which is big. But if you were doing it on a contest, you can also run it offline in a for loop. Like you can actually do this pretty easily in a for loop, and maybe it'll take I don't know, right? Like maybe it won't be interesting for a video, but maybe it takes 10-15 minutes to run and generate, and you get the 90 numbers, but it's doable, right? And then you just return like an array of the number, just like as a map lookup, so you can pre-calculate it that way. Right. So that would definitely give you the answer, right? Just like a for loop. And you just kind of, for each number, see if it's a palindromic integer. Pretty straightforward. 10 billion is, I don't know. I don't know how long it takes, but probably not, like you can do it offline, even if it takes an hour, right? Well, not great for contests, probably not so great for interviews, but doable, right? Okay, so let's that out, and there are a lot of optimizations things you can do, right? But Okay. How would I think about this? I was hoping this would be a little bit easier today. All right. I mean, I think we can play around with. Okay, so that's to be exactly n digit. That's the other thing with n digit is that it could be odd and even, right? Or those are the two kind of things, right? And what does that mean? So, right? I'm trying to think, right? So basically, okay, let's say you have n numbers or n digits. So then here, okay, let's say n is even without loss of generality, right? Or we'll go over the other cases in a sec, but as long as it's even, doesn't matter. So then here maybe we have some other variable. I don't know. Let's just make this big N, right? Big N is digits, and then small n is equal to n over 2, say, just to make it a little bit easier for us to talk about. N lowercase n, right? That means that, what does that mean, right? That means we have n degrees of freedom, kind of. That's not quite right, but basically, n degrees can be any number, right? I'm not thinking about the left half and the right half yet. It's just that these are the digits, and then we replicate them, right? So then here, maybe you can write like, okay, the final answer has, like, I'm trying to think whether we can enumerate it in this way, and I don't know that this is true, but we can, which is that, okay, how many ones are there, right? How many twos are there? How many threes are there? And so forth, and zeros. But the leading zero thing maybe is a little bit annoying. We have to figure that out. But I don't know. I don't know if this is a right way to attack this either. This is a, it seems like a tricky problem so far, right? But ignoring the leading zero for now, um, right? Then the actually it's not that many cases then, right? Because we say n is 10, so half of n is just, well, 10 to the fifth, which is like 100,000. There's only 100,000 cases, and here, and then we just do the math on. So there are only 100,000. I mean, at most, this isn't even quite accurate, right? This rearranging thing is a little bit awkward. That's why I'm trying to think through how do I handle this rearrange thing. Um, but basically, there are only 10 or at most 100,000 unique, or 10 to the fifth number of unique things, right? And what I mean by that is that, like, because you can take only half of it, right? So that means that given a 10 digit, you only have 5 digits that are unique because you're doubling them, right? So that's 10 to the fifth. Okay, that's fine, right? Can I do something with that? For each, because 5 factorial is what? Like 720 or something? No, that's 120. So 120 times, like if you do something like 5 factorial and the 5, I don't know, that seems a little bit weird. Feels a little weird. Um, So you could generate. So the problem is in generating a palindrome, right? So we can generate. There's only, like I said, 100,000 unique palindromes, but now we have to figure out what number arrange them. And and it's fewer than that because you cannot have leading zeros, but it's just like a number round, right? For example, if you kind of just enumerate like for 10 digits, you just kind of write it this way, right? As the left half of the palindrome, and then you can just kind of do this, right? And then dot dot dot, and then you can kind of see the pattern that there'll be 100,000 of these, right? So there's only 100,000 of these, and we're not even taking into account k yet, right? But these are the things that we can test. But then now we have to test the rearrangement, which I don't know. Especially, wait, is it before? So you have to rearrange into a k palindrome. So we have to find the k palindrome first, and then numbers that could be rearranged to it. Okay, that's a little bit different, but so of these 100,000, we'll filter it out by the k. Can you? And then you kind of do the maths. It's unclear to me. And I don't know whether I'm taking advantage of k yet, in the sense that it's only up to 10. So you could do like the divisibility rules, right, for most of them except for 7. Right, 7's a tricky one, which maybe you could do with DP or something. But or maybe you don't have to. Maybe, I don't know. I mean, maybe one hint is, and I don't know if this is a real hint, is that we've been doing digit DP the entire time. So why not think digit DP? I don't know why it took me so long to kind of at least think about it. It's been 15 minutes. Wow, we've been on this problem for 15 minutes. How is that even possible? Okay, so how would digit DP look like, right? Okay, so let's say, and I don't know how I solved these that clearly, apparently, even though it seems like I solved it before. But we have the number of digits left. We have the remainder. That's fine, right? This is for the k part, and then we have a bit mask, right? The bit mask will allow us to get the to keep track of the parity of every digit, right? So in a way, you can think about this as a Boolean array of 10 things, right? 0 to 10, or 0 to 9 inclusive, the digits, right? Because you can think about it as like maybe this mask is like an odd mask, and what I mean by odd mask is like maybe odd is equal to 4 times 10, right? So odd of 0 is equal to true means that there are odd number of zeros. So this is what it means, right? For example, and of course, if you think of it this way, then now we're just converting this bit, a Boolean vector, if you will, a bool list, into a bit mask, because here you just think of it as a bit mask is a bit of ones and zeros, and then for each digit you just kind of get it out. I think that's a good start. Maybe, I don't know if it's true, but I think maybe that we can think about it that way. I mean, and in analysis, left can be only up to 10, remainder could be only up to 0 to k, which is 9, I guess. Yeah, and mask can be just 2 to the 10, right? For 2 for each digit. Kind of sneeze. Right. Okay. So maybe maybe today I'm just struggling because honestly, when I first opened this form, I did think about digit DP, but I thought maybe there's some other funky way about it, and I don't know. I just kind of forgot. Sorry, friends. It's Friday night, so I'm really like off. But this is a hard problem, so I don't feel so bad. Right? I think that's it. Maybe I want to say. And that should be good, honestly. I mean, now that I think about it, if this is all the states, I mean, and it could be wrong, right? But if these are all the states. Wait. Yeah. Okay. I just always forget. I think it's easy to forget whether it's rearranged before or after. But okay. So I think given this, we should be able to do it because we did the math and it's not that bad, right? So it's like this is 1,000, this is 100, this is 100 or 90 really times 1,000, so we should be good. Okay, so then now the base case if we have no more digits, then if remainder is equal to 0 and mask is equal to yeah, if mask is equal to well, 0 is definitely true, but because that means that everything paired off. But it can also be whatchamacallit. If it's odd, then one digit or one of the numbers is not it, right? So we have to do like okay. So maybe we can even pre-calculate that, right? And for this problem for today, I'm a little bit tired already, and we're already 20 minutes in almost. I'm not gonna explain the dynamic programming portion too much. We're going to use cache, but yeah. So then maybe like good mask is equal to set, right? So if n mod 2 is equal to, so if it's even, then yeah, good mask is equal to good mask we add 0, right? Because that's only good mask. Else, you know, we just pre-process all 10 numbers where you have an extra 0 in the middle, 1 in the middle, 2 in the middle, dot dot dot, right? So yeah, so it's just good mask dot, if I can type it correctly, add you know 2 to the I, right? One of the digits being flipped. So yeah, so if it is in good mask, then we just return number count, right? So return 1, otherwise we return 0, right? Otherwise now we have n digits left or left digits left, a remainder and mask, and yeah, so we just try every digit, right? So we tried every digit. And keep in mind that we cannot do this for the first digit as a result because it has to be leading 0, so you have to handle it a little bit differently. That's fine, right? So here we have total for the count. And yeah, we add. Okay, so we used one digit, so that's the remainder state or the left state. Remainder is shift and add, right? So here we shift times k plus I, right? And then mask we used we flip it on the I, right? And that should be it actually. And now we have to loop over the first digit, which we have to skip 0, so it's 1 to 9. Yeah, right. And then that should be good actually. I don't know. As soon as okay, I mean, yes, Larry, as soon as you know the answer, the answer is easy. But yeah, so I mod k, and then the other one is right. All right, it's actually very well. Why is that? Why'd have 1 instead of 27? Let's see the other result first too. How do I get this back up? Okay, did I just put 1 for everything? No, I have a 2 here. Okay, huh. What am I missing? Why is it just 1? Oh, I forget to mod by k here, didn't I? Okay. I mean, now at least we're not getting 1 as the answer, because I guess it was not remainder 0, 0. But 44 is definitely too big. Okay. We have n minus 1. Yeah, that feels right. I minus I div k seems okay. Shift and add and mod mask. This is weird. This feels wrong, honestly, though. If the reason why this feels wrong is because this becomes nothing, right? So we just have I mod k. So there's something weird here. Is and I'm just being wrong today. I feel like on a good day I should know this, but I don't know how to. Oh, in the terms of like, you know, I know this is wrong, but I don't quite know how to fix it yet. Give me a second. But the reason why this is wrong is because this doesn't make sense, right? Because I was like, oh, mod k, or in the sense that like then this remainder doesn't do anything, right? Because you can remove the remainder and it give you exactly the same answer, you know, because that's how they cancel out. Though it's still a little bit low. So in any case, so what is the answer? What, how do I? It's not. It's shifting. That's okay. So you have 5. So it's no, it's just times 10, not k. Okay, that's why. I'm just being dumb on the shift. Okay. It's different wrong answer, so that's progress. But this one's right. Okay. Would always be right. Yeah, n is equal to 1. This should be easy. True. Also, they don't have n is equal to even numbers here for some reason. So, maybe that's an interesting thing. I hate the new UI, and it's been too long. Let's say I have something like this. Am I at least writing the even numbers? I just want to see. Okay, it just isn't really. Oh, no, it's not. We're not writing the even numbers. I guess we just have empty space, and for some reason it counts as successful. Okay. What am I missing? And the curious thing is that I'm both overcounting and undercounting, right? So that's weird, or at least that's just wrong. Usually, if it's one way or the other, you can maybe say that you're missing something, or you need to remove something, like you're double counting and stuff like this. But just being wrong is a little bit sad. Okay, let's see if we could try 2 digits real quick to see where we are at. So 2, we have, let's just say 1, and then 2, let's go to 5 maybe. I can give it a spin real quick. Also, friends, I've been watching the Black Mirror recently. Let me know in the comments if you've been watching it. I mean, it just came out, right, as of this video. So, okay, so 2 digits, it's okay. So am I just messing up on the odd numbers? I think that's the question of. That's why I'm doing this, is because I'm not sure that maybe like, you know, like maybe it's an odd even thing, and I'm just like messing up on the. Yeah, all the even numbers I'm okay. And I guess there's only a maximum of 8 cases or something. I don't know, right? Because it was not showing the other ones. Oh, silly Leetcode. Okay, so it's not all good, because 4 we definitely have wrong, and okay. So why is that? Or is so maybe? Oh, I think I did it. I was trying to be careful about this, but I think I did it wrong anyway. Because you have to. Because I did the. Because I was considering the rearrangement part. Okay, I see why I'm doing it wrong, but I don't know if there's an easy fix for now. But I looked at the rearrangement part, and this does handle the rearrangement for the palindromic part, but not the K part, right? Because I checked that the remainder is equal to 0. However, like even on the first one, right? 551 is good, but 551 does not divisible by 5, which is what we check here for remainder. So this is wrong. I don't know how to fix it necessarily. I mean, there is some like okay, so I mean, definitely wrong. But okay, let me rethink about this for a sec. I'm trying to think whether we can use divisibility rule, right? For example, if k is equal to 1, then you don't have to worry about it. If k is equal to 2, then you check whether there's an even number in the thing, right? And that means that you can always map to something, right? If k is equal to 3, for example, so something like that. Like if k is equal to 3 is the one where you sum all the digits, but I don't know that I can or want to write a DP for all of those, and I don't know how to handle 7 anyway. But sorry, so that's what I was gonna say. Maybe it's necessary, but I don't know. Like, how do you do 7 anyway with divisibility rule? Am I just forgetting it, or is that like the alternating like add subtract? Or some crazy thing, something like that. I feel like I do remember this actually, but I don't know. Right? I'm trying to think whether you can do it at a time. And then the other thing is that maybe we have to do that 100,000 thing that we talked about, right? And then just then that requires you to know, like, it's hard to do a DP that way because it requires you to know the intermediate things. Yeah, this was messed up. Alright. Huh. Like, yeah, if you have k is equal to 5, that means that if you have at least a 5 or a 0, then you can and the rest being true, then you can always be good. But again, I don't want to write a DP for every k. And if there exists a k is equal to 7 solution, then we should have a general one anyway, right? Right. Huh. Now I'm stumped again. I thought I was close, but I misunderstood the problem. Okay, well, man, I honestly right now I don't have any idea, so I'm just trying to think real quick. Maybe that's why I didn't have this, but then I just kind of got carried away. Okay, so we want to. My idea right now is just try to think. How hard it is to generate all the k palindromic numbers. Right? Because, and how does that even help? I don't know. Well, Huh. I mean, and just to be clear, if we had a for loop running in the background, we would be probably finished running about now. So I don't know, by now. But Okay, I mean, let's say we have someone like this still. I don't know how to do this remainder part. Or the remainder has to be afterwards, right? So, okay. So, I mean, this counts the number of... Why does this under or over count? So this is... Oh, because it's rearranged. So, is because we cannot do both, I see. I mean, we can enumerate it that way. I'm trying to think, how do you count the number of palindromic things? But then how do you do the rearrangements? Because I have two strategies that I'm trying to figure out which one it leads to the right way, right? One is that we can come from the direction of, okay, we have all these integers or all these numbers that are good, and count the number of ways we can rearrange them, or we could generate all the good numbers to begin with and then count the number of ways to rearrange them into the good ones, right? Or into k palindromic or something. And either one doesn't really sound like a reasonable thing for me right now. Um, that's why one. Okay, that's why it is wrong for stuff. That's why it is right for n is equal to 2. Because for n is equal to 2 is always true, right? Because with the palindromic, they have to be the same number. So that's why this works, but that's not really helpful. Huh. And how do you even do it even when we want to? Even, okay, so I'm just exploring if we want to do it by k analysis. Okay, something is divisible by 4 if it ends, or the last 2 digits is divisible by 4. Wow, I really have, and it cannot be a leading 0, so that already cuts on some of the stuff. But I mean, this is not salvageable, but I'm just leaving on the screen. I don't know why. Sorry, friends. Wow, I just feel so odd. Like for k is equal to 2. Okay, so you have 10 numbers, right? What's 10 choose 5? 10 choose 5 is 252. Is it possible to just generate them all? And then just do the math that way? Yeah, so what I'm thinking is just like, just generate every possibility. Okay, so that would allow you to generate the possibility for palindrome, but not the k part, right? How do you handle the k part? So given a group of things, how do you okay, so let's say you have 10 numbers, right? What is the maximum number of distribution, right? That's what I'm trying to think. Like, is it 2 2 2 2 2, right? And it has to be, of course, palindromic. So in this case, it'll be what, 10 factorial over 2 factorial over 10 which is like 10 over 2 to the 5th or something. That's 113,000. That's How do you even do it? Maybe today, I don't know. Maybe today you just. Maybe this is the day where you just stare at a confused Larry. But. I don't know. This isn't right. I mean, this is right. But then now what? Now you still have 10 factorial waves of. No. For each of these, you have 100,000, right? Ways of permutating, hoping that one of the ways is a palindrome that is divisible by k. Okay. Is it easier to kind of. I'm trying to think whether. Maybe we can just generate them. Maybe I'm just being dumb in terms of analysis. Like, yeah, right, like, okay, let's say n is 0 to 10, so you have just for I in range from, I mean, I'm just writing it very dumb right now. Right, so that's, nope. Right, something like that, and then you have like string I plus string, yeah. Basically, just create a palindrome. I'm doing it very ineffectively right now, but I just want to think about this, right? So we have a palindrome, whether this is marked by k, right? So okay. So if this is 0 to 0, we in the count, print count, right? And we want k to. I just want to see the 7 case, right? Because the other cases is pretty straightforward, and apparently there are only 13,000. So maybe I overanalyze this, right? Because the 7 case, we only have to store 13,000 numbers. Right, so then now we can store this. And also because this is true, we can sort the digits. And then like, so, okay, right? So for example, if this is 7, yeah, right? And we could maybe just print one of these or two of these just to kind of confirm that I'm not doing this math wrong. I don't think that I'm wrong though. Yeah, right, because it's just do it. Okay, and there's about, they say, well, I printed this before. Oh, no, I printed it after. So there's only about 10,000 of these, right, they say. And then now it's just about, okay, so let's say you have this thing, right? So here, you have, we want to convert this to a list, or maybe more accurately, yeah, I mean, you can write oh no, this is fine because it doesn't have any leading zeros. But then now, so this is the end result, right? So these are all k palindromes for 7. Right, so here we're just trying to get the key is you go to, I don't know. Right. I mean, this isn't quite working. I don't know what am I writing, huh? Something like this, right? And then now we want to key it, which is fine. Actually, probably could have just win. That's why I want to write it the other way about. Well, either way is fine, honestly. But yeah. So we have like this thing as the key, right? And then here maybe we have a set, something like that. So you could kind of see the number of distinct ones. So only 1,000, just 800 distinct things. And then for each of these, we can just count the number of permutation. So maybe that's the way to do it. I mean, if we can do this very fast on every single thing, and this is probably the worst case, then maybe that's fine. Because for each of these, then we can just do the math for how many ways you can permutate. All right, well, let's try it. I don't know. All right, so here, okay, because I spent I don't know if this works still, but I think I spent too long analyzing it instead of doing it. I think that's definitely not a great thing, but yeah. Yeah, okay, let's solve for n is even for now. We'll ignore the odds intentionally, because, well, if it's not correct for even numbers, then, you know, it's not going to be matter anyway. So we need both. Okay, so you have something like this. So here we have k, right? Let's say we got rid of k. Is that slower? It should be slower, right? Because if k is equal to 2, if k is equal to 2, then we're doing this for more numbers. So maybe that's fair. But yeah, we can actually, and I was going to actually keep it here, but actually maybe I'm wrong. Like, maybe, okay, no, okay, Larry, focus, don't prematurely optimize. What I was going to do is maybe we could pre-process this, but at least for now, until we get the right answer, let's not prematurely optimize. So yeah, so n is the number of half the digits. So we want something like power of 10 to n, right? So if it's 10, then it's 10 to the 5th. N minus 1 to, oh no, n, right? N to the 5th is 10,000. Yeah, okay. So something like this, and then, yeah, so is it still the same? Okay, 10,000, 1470. Okay, that's definitely not right. Oh, wait. Oh, I see, because the other one was when n is equal to like 10 or something. That's very slow. Huh. Was it 10 before? Didn't we do 10 before? Huh, I don't know anymore. Alright, let's see. In any case. Alright, fine. I don't know. Okay. What are we outputting? Oh. Well, that's a very weird output to be outputting. It's fine. I don't care. Okay, so we have 10, 10 for 2s. For 4, we have 164 unique ones. Right? And then now for each one, we can count. I guess that's the biggest thing, right? So now we have key. So then now we can search for the key, right? So here, yeah. So for S, for X, for X and S, right? Here we try to count the number of ways we can do it this way, right? And it is just going to be n factorial, right? So yeah. Divided by, I guess it's just this, and then for k in S, not S, oh, I guess we have to do the collections thing again. Well, maybe not again, but for this time, right? So for key, it's just the value actually. The key doesn't, oh, well, it does, it actually matters because of the 0 case. But maybe it doesn't matter for, okay, we'll ignore the 0 case for now, and then it's just this, right? Something like that, and then we should be good, maybe. Right, okay, 0 is not what we expect. But we have 10 numbers in here, we have, what is it, 2 factorial over, Oh, I think this is because this is a string. Oh no, that's John of value. So, but why do we have 2 of? That's definitely wrong. Did I do this wrong? I mean, probably. Definitely not doing it right. Okay. So for 2 digits, did I double this? And so there should be 1, right? So 1 goes from 10 to 100. No, so I'm just wrong right here. 10 to the 5th. Yeah, no, I just had it wrong. Okay. I had it right the first time, but I just was. I guess I just suck. Yeah, okay, so this is good. Yay! Case equal to 8. 4, we don't expect 4 to work yet because we have the 0 case. So actually that undercounts anyway. I thought it would overcount. Yeah, I thought it would be overcounting, to be frank. So I'm actually a little bit surprised. That's why I'm like giving a pause. Dramatic pause. Okay, so this is all the palindromic things of 2s. Right? But that's not quite right? Because for each of these, why is it not printing one of these? Oh no, we are. It's just that I had to click on view more and I didn't realize. Okay. So we have 4 factorial. So I don't know why the output is 1, because for this is 4 factorial over 4 factorial, which is 1. So then we should. Oh, I'm dumb. This. Okay, I'm just dumb. Okay, fine. I mean, yeah. I'm. For some reason, I was only thinking about one of the cases, and then I just. Today's a weird day, I suppose. Okay, so this overcounts. Okay, now we're correctly overcounting, I think, in that we don't consider the zeros, right? Because we overcount the ones with leading zeros. So then now we have to consider the zeros, right? I think one lesson here is, don't always, especially when you run out of ideas, don't underestimate the power of just doing it and pre-processing and all these things. Yeah. Okay. So what do we have here? So how do we do 0? So then here now, if okay, so let's just say f is equal to this thing, right? And then okay, if f of 0 is greater than 0, then what happens? Well, here, let's say we have, I guess we'll do it. So we have 0, 2, 2, something like that. What does that mean? That means that the first digit, so okay, so you have 4 factorial. Is it? No. Because the first number is fixed in this case. I mean, technically, it is the number of unique keys minus 1 because you cannot be 0, but okay. Right, so the first digit, we have to set number first digit, which is the number of unique things, and then now the rest, right? So we have to do it in a, so you have to do a second for loop, I suppose, right? Okay, so then now the first if, okay, we have to do a right? So, or, okay, so I was going to do it that way, but we can also do, so you can sum up all the other, so this is not a great example. Well, there are only 4 digits, so there are no other examples, but let's say you have like, 3, whatever, right? Is your key. The idea then is that, okay, my first initial idea is, okay, fix the first digit. So now we try, okay, first digit is 2, then do the math for the other ones. First digit is 3, do the math to the other ones. The first digit is 5, and then sum them up, right? But I think you can actually do it the other way where, okay, we already got the total of all these, then maybe we can just fix, okay, the first digit is 0, and do the math to the other ones. So, okay, so yeah, we can do it that way. I think that's, well, you only have one case, so mathematically, or computationally, it is faster, at least. So if this is the case, Then we fixed one of them to be the first digit. I mean, and we just do that. There's no magic about it. And then the rest of the digits, it's going to be n factorial minus 1. Also, we do a lot of overwork here, so maybe we can pre-calculate this, but I'll do that later. It's fine. If it runs out of time, there are things we can do. If we run out of time, I'm not going to forget to do stuff like that, but it's fine. Okay, so one of the first digit is 0. We have 0 current maybe, I don't know. And then for now we do need to. I mean, everything else is the same, except for if it is 0, right? So if k is equal to if k is not equal to 0, then we have this. This double negative is a little bit bad, so we'll actually write it this way, right? So 0 current v minus 1, right? So something like that. Is that the 0 case? Oh, we have to subtract. Oh, maybe I mean, we just did the math, but we didn't contribute. Okay, still wrong though. Why? Print 0 current, just to have something to print that we're not returning 0 for. Okay, so that we should have something print. So that means that this is string 0. Silly way I wrote it. Okay, I mean, it's not enough, but maybe that's fine. Or like, I mean, it's not fine enough, but it's a good start. F current. Let's see, right? So we definitely still overcount. What is this? Oh, this is just for. Wait, where's that 1 coming from? Don't we only have print? Oh, print here for the 0 current. Okay, so that's 5. Is that 5? So 0 to 2. So that's just 3 factorial over 2 factorial. Yeah, so it should be 3. Why is this 5? So maybe my way of doing it is not right. Why is it not right? We fixed. Oh, I see. It's this times the number of zeros, because they're a distinct way of putting. Okay. Okay, this is closer, but still wrong. The reason is because fix one of them to be the first digit, but it can actually be whatever the number of 0 of them can be on front, right? So that's basically why. Okay, I think the math is better, but not quite right, clearly. Math is hard. Okay, so for 6's, 1 is right, 2, 2, 5, 5, I guess that's probably right? 0 to 8, is this right? I guess this is the critical one. If you have 0088, then you have 8008, 8080, and then 8800, right? So that's 3, and I'm putting 4, so that's why we're off by 4, because we have 4 of these numbers. And the reason why, okay, so I mean that's not great, but so the math thinks that it should be 4 factorial, or the math that I've been doing is this, which gives 6. All right, so this is 6, and we subtract the 0 case, so it's going to be 088, 0808, 0880. Yeah. Right? Is that what my code is doing? 3 factorial over 2 factorial is 3. trying to think, is that what I'm doing? Because that doesn't seem to match up, right? So 0, 0, okay, so we look at this as 4, which is too much, but what I was saying is that it would be, okay, so these are the order possibilities, but if you want to go all the order possibilities, it'd be something like this. Well, it's this plus this, but then we want to subtract this out instead. Why am I not subtracting this out correctly? Well, 0 current is still 1. Okay, so I did 2 times 1, which is what I thought may be right, but it's definitely still not right. Because 0 current should be 3, because this should be 3 factorial, and this should be just 2 factorial on one of them and 1 factorial on the other one, right? So why is 0 current? Let's see. Am I just being dumb? Okay, 6 and then 1. Why is this 1? Am I being dumb? I mean, yes, but... okay, so it's 1, and then you have this, and it should be just 2 factor. Oh, it's this thing. Okay. I didn't... Yeah, because I was comparing... Okay, that's what happens when you sloppy with the strings and ints. Okay, so now we're good. Okay, so now we're good, right? And for even numbers, maybe I don't know if I'm confident, but I mean, the math was right. I had the math right. It's just that programming is hard. So okay, so this probably works for even numbers. I mean, of course, yeah, let's actually try like an 8 first, right? So 8 and 7 would be a tough one. 8 and 2, 8 and 4, right? If it works, then I have higher degree of expectations, and it works, right? So okay, so we're happy about this. And then now though, the odd ones, right? I mean, it shouldn't be that much more different. I mean, I don't think this doesn't change. It's just about updating these things. So yeah, so that should be okay. So then it is that, and it's just about, yeah, and the same complexity, I think. So yeah, okay, so n is mod 2 is equal to 0, then we have this thing, right? Otherwise, we have are the numbers right? So if we have 7 digit divided by 2 is going to be 3. So that means that we have starting from 100, and then we add an extra number in the middle, right? So here, right? So m in range from, I don't know, from 0 to 10, and then it's just this plus m plus, yeah, right? I mean, it's very ugly, but should work. Okay, we have to try the other things first. How do I get the how do I reset the test cases? I actually don't know. Like, there used to be a button specifically for it. Reset test cases. Okay, it's just okay. Float is not. That's weird. I'm not doing divisible. What? Oh, if this is 1, if n is 1, then if n is 1, then this is -1, which is why this is a fraction thing. Okay, well, this is just annoying, I suppose. I mean, if n is 0 to 1, then we just kind of do the loop, I think. Here, we don't have to worry about it. Okay. The zero is zero not a positive whatever? I guess not. Okay, fine. So we start at 1. Okay, so at least now we're okay with also the odd numbers, but we'll try a bigger number first as well. I don't know, 9, 7 is the one that I always worry about, but maybe not. I don't know. All right, so let's give it a quick submit. Quick submit after an hour of things, and we're good. I wonder what I did last time. When I did it, I was gonna do some optimization actually, but that was almost a year ago. So I guess I kind of did it the same way. Okay. I thought this would be too expensive, honestly. But because this is 100, maybe not. Maybe I should. Now that I think about it, I guess not. But I don't know. For some reason, I did as I did. And yeah, there's some optimizations that you can do. For example, you can pre-cache all the factorials, right? We only like these two ones, for example, fact n. I don't know that this matters that much, but it does bother me. Though, yeah, I mean, you can also cache. I mean, there are only 10 numbers. We could probably cache everything. I'm just gonna submit real quick. Just I want to, like, we can optimize the other one, but I wanted to know whether this would have been faster. So no, not that much. Okay, maybe it's not that much of an issue. Yeah. I mean, there are additional things you can do with caching, right? Because, for example, I usually. Right. Like, it's just about finding the right S. So for example, you can have I don't know, get numbers for n and k, right? So you could definitely, I don't know if this is that useful actually, because then if you're going to cache that, you might as well just cache the answer, right? So maybe that's fine. And this is relatively fast, even though it's annoying writing. Yeah. Yeah, that's all I have for this one. I think I don't think that I have any more. If you watched this entire thing, I'll probably redo the intro a little bit. So, but yeah, because it is just actually brute force trying everything and then doing the math afterwards. So I'll probably do the explanation in the beginning. And you just, if you're watching this, then thanks for watching. Leave a comment about Black Mirror and whether you're watching it. And yeah, and I'll do the explanation in the beginning, so I'm not gonna keep going because I'll I'm gonna record the explanation and I'm gonna cut it in the beginning. So, all right, yeah. Thanks for watching. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye. Oh, and have a great weekend, everybody. Bye bye.